Alright, in this video we're going to take a look at the different problem types that appear in your Unit 4 test review for Math 101. So the first question we'll take a look at is question 1, where we're asked to determine if the ordered pair is a solution to the system of equations. And in problem 1 I'm going to do part B here for you. Well, the first thing that we're going to have to add here is that this is a system. That little brace on the side, it wouldn't be a system, so I forgot to add that into the worksheet, so we need that on there. And so what that tells us, because I have that brace on there, is that this ordered pair, negative 3, 4, in order to be a solution, has to work in both of these equations. So I'm basically going to plug that point into both of these equations and check to see if it works. So I'll go ahead and plug it in the first equation there. So I'd have 2, my x value then is negative 3, and then plus 4 equals negative 2. We're just going to see if that works out. Let's see. 2 times negative 3 is negative 6. And negative 6 plus positive 4 is negative 2. So it checks in the first one. So let's go ahead now and check it in the second equation, because it's again need to work for both of these equations. So I'd have negative 2 times negative 3 when I plug that in for x, and then positive 4 when I plug that in for y equals negative 6. Let's do some work on the left side here. Negative 2 times a negative 3 is a positive 6. And then a negative 3 times a positive 4 is going to give us a negative 12. And then 6 minus 12 will give us negative 6. So it works in the second equation. And so since this point is a solution to both of these equations, it is also a solution to the system. So we would say yes, it is a solution. Okay, next question we'll take a look at is question 2, where we're asked to solve this system graphically. And then we're asked to clearly state our solution. Well, solving a system graphically, and again we'll start by adding my brace there. Now it's a system of equations. Solving it graphically means we're just going to graph both of these equations and figure out where these two equations cross. So both of these equations right now are in standard or intercept form, where we have something x, something y equals some number. So the easiest way to graph in standard form is just using the zeros. So I'm going to start with this first equation, 2x minus y equals negative 2, and I'm just going to find my 0. So I'll put a 0 in for x, that would give us the y-intercept. Put a 0 in for y, that would give us the x-intercept. So let's see, if I put a 0 in for x, I'm going to be left 2 times 0, well, I'll just write this out. 2 times 0 minus y equals negative 2. Well, 2 times 0 is 0, so I'm left with this statement, negative y equals negative 2. Well, for that to be a true statement, we're going to have y is 2. So I'll go ahead and put a 2 in there for y. Okay, looking at the second point, now I'm going to put a 0 in for y. So I'd have this 2x minus 0 equals negative 2. Well, minus 0 is really just the same thing as nothing there, so we're going to have 2x equals negative 2. For that to be a true statement, then x would have to be negative 1. So now I have my 2 points. I can graph this equation over 0 up 2. Gives me my y-intercept. And then negative 1 left, negative 1, 0. Gives me my second one. So I'll go ahead and graph this. Okay. Now I'm going to go ahead and graph my second equation. I'll give myself a little room here. We'll erase this. Okay. Taking a look at my second equation now. Again, I'm looking at negative x plus 2y equals negative 1. I'm going to use the zeros again. First find my y-intercept, then find my x-intercept. So let's see, if I put a 0 in for x, I'd be left with this statement. Basically 2y equals negative 1. I'd divide both sides by 2 and I'd get y equals negative 1/2. So I have negative 1/2 for my first point. For my second point, I'm going to put a 0 in for y, so I'd basically be left with this statement, negative x equals negative 1. And so for that to be true, x is going to have to equal positive 1. X will have to equal 1. So there's my next point. So I'll go ahead and graph that. So over 0 up a negative 1/2, my first point. And then over 1 up 0 would be my second point. So right there. So I'm going to graph these. Oops, I missed my point there. Let's try that again. Okay. Now you can see that these points intersect. That's going to be our solution where these two points intersect. Now that is not on a point. We're just going to have to kind of ballpark or estimate that. So I'm looking at this point right here, trying to estimate where that intersection occurs. Now, since we're graphing and we're not totally accurate here, anything close to this estimate that I get is going to be great. So it looks like in the x direction we're moving negative, but maybe not quite -1. So I would say maybe -2/3 for the x movement there, or something close to that. We're a little more than halfway. In the y direction, I'm moving up maybe 3/4, so +3/4. So as long as we're coming up with a solution that is close to that point, that's great. And so this point represents the solution to the system of both of these equations. So now we'll take a look at questions 3 and 4. And in questions 3 and 4, we're asked to tell how many solutions to these equations without actually graphing these. And so what we want to do is we just kind of want to get a mental picture of these equations and figure out whether they're going to have one solution, which means these two lines would cross. They'll have one solution. No solutions if these lines are parallel and they don't ever cross. That would be no solutions. Or if it's exactly the same line. If these equations both represent the same line, then we'd have one equation graphed on top of itself and we get infinite solutions. So that's kind of what we're looking for in questions 3 and 4. So let's take a look, starting with question 3. We're asked to determine if there's going to be, no solutions or infinite solutions to these. And again, I need that brace there to say this is a system of equations. So if you take a look, both of these equations are in slope-intercept form. And both of these equations have the same slope. When the equations have the same slope, which in this case is 6, that means these lines are either going to be parallel or they're going to be exactly the same line. Well, you'll also notice that these lines have a different y-intercept. So here's kind of the mental image that I'm getting here. And we're not graphing, but I'm just showing you this here to kind of see what I'm thinking. So the first equation has a y-intercept of 2, so let's say that's about right there. And this is a slope of 6. That's a pretty steep slope, so let's say that line is traveling up like this. And the next line has a y-intercept of -3, but it has the same exact slope. So you can see we're going to have parallel lines there. So this system of equations is going to have no solution. So how I would state this or support this mathematically, I would say both equations have the same slope. With a different y-intercept. So they are parallel. This means or indicates no solution. Okay, let's take a look at question 4 now. Here we have our equation. It's not in slope-intercept form, so that's going to make it a little bit harder to figure out what's going on. So let's go ahead and manipulate this thing so we get it in slope-intercept form. So let's take this first one, 4y minus 2x equals 2. Let's get that in slope-intercept form. So I would add 2x, 4y equals 2x plus 2. Divide everything by 4. So I have this y equals 2/4. When I simplify, that would be 1/2 x, and then that was a positive 2 divided by 4, so plus 1/2. Okay, let's take a look at our next equation. Get that in slope-intercept form. Add 3x. So I get 6y is equal to 3x plus 3. Divide everything by 6. So I have 1/2 x when I simplify 3/6. plus, and then 3, 6. I simplify that again. You'll notice these equations are exactly the same line, which means if I were to graph these, one would graph directly on top of the other, which would indicate then an infinite number of solutions. So I would say both equations are the same. So this means or indicates infinite solutions. Now we'll take a look at question 6. In question 6, we're asked to solve this system of equations by the substitution method. Again, we'll have to add our brace there to indicate that this is a system of equations. Okay, and so with the substitution method, we want to isolate one of the variables and then substitute it back into the other equation. Well, this question 6 is actually really nice because you can see that we have x isolated right there. We know what x is equal to. So we are going to take that value, or sorry, that expression there, and put that back up into the other equation for x. So let's take a look at what that would look like. I'd have a 2, and now I'm multiplying by that whole expression, which is negative 5y plus 14, and then minus y equals 5. So all I've done is taken this expression right here, this negative 5y plus 14, and I've substituted into the other equation for x. And now what that does now is it gives me an equation over here that has just one variable, y, and we can solve this equation just the way we've always solved equations in the class. So I'd start by distributing the 2. So let's see, that'd be negative 10y plus 28 minus y equals 5. Okay, now I'm going to combine my like terms. A negative 10 and a negative 1y will give me a negative 11y plus 28 equals 5. Now I'm going to subtract 28. So let's see, then I have negative 11y. And let's see, sorry, I made a mistake here actually when I was writing this equation. This was supposed to be a negative 5. Negative 5, negative 5. So now when I combine that negative 5 and that negative 28 together, that's going to give me a negative 33. And now I'm going to divide both sides by negative 11. And so then I get y is equal to a positive 3. So I'm halfway done. To solve the system of equations, I need both the y and the x coordinate. So what I'm going to do now is I'm going to take this y value. I know now that y is 3. I'm going to substitute that back up into one of these equations. And if we substitute it back into the equation that's already solved for x, which is right here, that's going to make it a lot easier to come up with this answer. So let's see, I'll have x is equal to negative 5, and now we're substituting that value of y, which is 3, plus 14. So let's see, x equals negative 5 times 3 is negative 15. And then negative 15 plus positive 14 is going to give us negative 1. So now I have my two values, and I want to express these values now as an ordered pair. So I would write negative 1, 3 as my solution to this system of equations. Now we'll take a look at question 9. In question 9, we're asked to solve this system of equations using the substitution method. So the first thing we'll want to do is get that brace on there to indicate that this is a system of equations. You can see again that y is already isolated here. There's y, it's all isolated. So all we're going to do is we're going to take what y is equal to, this 3x minus 4, and we're going to substitute that back in for y in the other equation. So here's what that will look like. I'll have 9x minus 3 now times this quantity, 3x minus 4. That's what we're replacing y with. So that's going to equal 12. And now again, I have an equation now that has just one variable, and I can go ahead and solve this equation just like I've always solved our equations. So I would first distribute the negative 3. So let's see, I'd have 9x, then minus 9x plus 12 equals 12. All right, now I'm going to combine my like terms, and you'll notice I have 9x minus 9x. Well, 9x minus 9x is 0. So what I'm left with here is I have this statement, 12 equals 12. Now remember, when we solved equations with one variable, if the variables dropped out and we had a true statement, that meant we had an infinite number of solutions. Well, that indicates exactly the same thing here when we have a system of equations. So variables have dropped out. I have a true statement. So this indicates that these two equations are actually the same line. And so I have infinite solutions here. So let's see, infinite. My n didn't come out so well. All right, so I have infinite solutions. Had the variable dropped out and I had an untrue statement, so let's say I was working a problem and I had something like this, 12, but on the other side of the equation I had 13, a statement that was untrue. That would indicate to me that these two lines in the system are parallel, and then I would have had no solution. So you're probably going to see some of those in your test review as well. So variables drop out, an untrue statement, that indicates we have no solution to the system. Okay, now let's take a look at question 12. Question 12, we're asked to solve this this story problem using a system of equations. I know that I need to use a system here because we have two unknowns. When you look at the end of this question here, how many adult tickets, how many children's tickets were sold, that is two unknowns. So I want to first identify these two unknowns. So I say x equals, y equals, let's let x equal the number of adult tickets. Okay, and we'll let y equal the number of children's tickets. Okay, now I need to set up my system of equations. Now, most of these systems of equations are based on some sort of total, and this type of problem is. So the first total that we have here is that there are 450 people in attendance at this show. So that's going to be one of my totals. The other total that I have is that at this show they've collected $3,750. So there are my two totals. Now I just need to go back and write my equations. So how do I come up with this 450 people in attendance? Well, if I added the number of adults that attended, which is their ticket sales, plus the number of children that attended, I'd end up with this $450. Now my next equation, I need to come up with a monetary value, a kind of a total money that they collected for the show. Well, if I take the number of adults and I multiply it by 10, that would tell me how much money they collected in adult ticket sales. So I could go 10 times x, that's the amount of money they've collected for adult ticket sales. And now if I add to that the amount of money that they collect for children's ticket sales, which is right here, they get $5 for each child. So if I take 5 times the number of children, which was y, that will tell me how much money they've collected for children's sales. Well, if I add those two sales together, I should come up with this $3,750. Now that I have my two equations, I'm going to go ahead and solve. It's easier to isolate one of these variables up top, so I'm going to isolate x in the top equation. So I'd subtract y. Here's what my equation would look like. It would be x equals 450 minus y. So that's what I'm going to substitute now in the other equation for x. So let's take a look up here when we solve that. So I'll have 10 times this quantity, 450 minus y, plus 5y equals 3750. Okay, distribute the 10. 4,500 minus 10y. Okay, I have like terms on the left side. I'm going to combine the negative 10y and the positive 5y. That would give me negative 5y equals 3750. Now I'm going to subtract 4,500 from both sides. And I have negative 5y. When I do that subtraction, I get negative 750. Divide by negative 5. When I do that division, I get 150. So I'm almost there. I've gotten y, which was the number of children's tickets sold. So we know that that is 150 children. And now I just need to find out the adults. So I can plug this probably back up into this equation right here to find out how many adult tickets were sold. So I'd say then x equals 450 minus 150. And so let's see, then we have 300. So now I need to make sure I answer the question. So we have 300 adult tickets, and 150 children's tickets. Now we'll take a look at question 16. Question 16, we are again want to use a system of equations to solve this. I know that because our question is how many pounds of each kind. So they're looking for two things there. So I know automatically I got to go use a system for this equation. So we'll say x equals something, y equals something. Now let's see what is x and y going to equal. The mixture is obtained from two kinds of candy. We have Jolly Ranchers at $6.50 per pound, so they're selling this per pound. So I want to make this the pounds of these Jolly Ranchers as my first unknown. And then the other thing is pounds of Skittles right here. Skittles at $8 per pound. So that tells me I want pounds of Skittles. Okay. Now I'm going to set up my system of equations. And again, I think here we have totals in this particular problem. The first total is that altogether here we're going to have 50 pounds of this mixture. The second total that we're coming up with is that in the end we want this candy to sell for $7.40 per pound. That's a little bit tricky, but we'll figure this one out. So $7.40 per pound, if I want to end up with a mixture that costs that much, but I also have 50 pounds of that stuff, I am going to need to take that $7.40, the price of that candy, and multiply it by the 50 pounds. That's my other total there. That's going to kind of give me a total price for this these two candies getting mixed together. Okay. Now once I have my totals, I'm going to go ahead and write my equations. The first one is easy. We want to come up with 50 pounds of this. Well, if I take the pounds of Jolly Ranchers, which was X, and add the pounds of Skittles, which is Y, I'm going to come up with 50 pounds. The next case, I kind of want to come up with a total price. So to get a total price, I'm going to have to take the price for the Jolly Ranchers, which was $6.50 per pound, and multiply it by the pounds that I'm going to use of the Jolly Ranchers. Now I'm going to do the same thing for the Skittles. Skittles were $8 a pound, and I want to multiply that times the pounds of Skittles. So now that I have my two equations set up, I'm going to go ahead and solve this. Again, I'm going to isolate one of these variables up top. I'll isolate x again. I'd subtract y from each side, and I'd have x equals 50 minus y. And so this is the quantity that I'm going to substitute back down into my other equation. So let's see, we'll put that in for x right down there. So then let's see, I'd have 6.5 times 50 minus y, and then plus 8y equals, let's go ahead and get an answer to that multiplication there for that total. 7.4 times 50, 370. Okay. Now I'm going to distribute this 6.5. So let's see, 6.5 times 50. It's going to give me 325 minus 6.5y plus 8y equals 370. Okay, let's come over here to finish the problem. So let's see, I'm going to combine like terms. So that 325 is going to stay as is. Now I have a negative 6.5 and a positive 8. That's going to give me a positive 1.5. When I combine my y terms, equals 370. Okay, now I want to subtract 325 from each side. So then I have 1.5y equals, let's see, 40. 45, because if that had been 75, it'd be 50. So 45, and so I want to subtract, or sorry, divide by 1.5. Let's see, 45 divided by 1.5 is 30. So it looks like now I found the pounds of Skittles. So I have 30 pounds of Skittles. And I plug that back into the other equation when they're supposed to add up to 50. So that leaves me with 20 pounds of Jolly Ranchers. Okay, final question we'll take a look at is question 19. And question 19 is again, we're going to use a system of equations to solve this. How many liters of the 80% alcohol solution and the 25% solution? So they're looking for both the 80% solution and the 25% solution. So we know we have two unknowns here, so we're going to use a system to solve this. So I'll let x equal the 80% solution. And I'll let y equal the 25% solution. Okay, and now I'm going to set up my system of equations here. And again, we have some totals in this problem. So one of them is 10 liters. She would like to make 10 liters of the solution. So in the end, she wants to have 10 liters of solution. So that's one of my totals. And to get that one, all I'm going to do is add both the amount of this 80% solution and the amount of this 25% solution. So I'm just going to say x plus y is going to be 10 liters in the end. And then the last one, we want to come up with a percent of the solution. So in the end, the final thing we want to have is we want to have 10 liters of the solution that is 60% alcohol. So that's kind of our total there, or what we want to end up with. So to get that, I'm going to take that 60% alcohol, which is 0.60, and I'm going to multiply that by the 10 liters. Okay, so you notice I'm taking the percent of alcohol times the liters, and that's how I want to set up my left side of my equation. I want to take 80% alcohol, which is our x value, so I want to do 0.8 times x. That would tell me the amount of alcohol I get from x liters at 80%. And then I want to also take 0.25 times y. And so you'll notice here, this last equation is a little bit tricky to get, but it's actually not that hard. With these solution problems, we're always ending up with something like this, where we're taking the percent and we're multiplying it times the amount of that solution. So you'll notice all of those terms here in this equation end up just like that. The percent times the amount. Here we have 80% times the amount, 25% times the amount, and finally 60% times the amount. Okay, I've got my equation. I'm going to isolate one of the variables up top. Again, I'll do the same thing. I'll isolate x. So x is going to equal 10 minus y when I isolate that. So I'm plugging that 10 minus y over here for x. So let's take a look at what we have. We have 0.8 times this 10 minus y, and then I have plus 0.25 y, and then equals 60, or 0.6 times 10 is just going to give us 6 when I multiply that together. Okay. On the left side, I'm going to distribute the 8. So that's going to give me 0.8 times 10 will give me 8, and then minus 0.8y plus 0.25y equals 6. Now I'm going to combine my like terms there. If I combine negative 0.8 with 0.25, that is going to give me a okay, so when I combine the negative 0.8y with the positive 2.5y, I get 0.55y, and that was negative because I had 0.8 was negative, which is a larger number. Okay. Now I'm going to subtract 8 from both sides. So I have negative 0.55y equals negative 2. Now I'm going to divide both sides by negative 0.55. When I do that division, I get a positive 3.636, so I'll just round that to the hundredths place, so 3.64. So I found now the 25% solution, so I would say 10 minus 3.64, and that would give me my x value, which is 6.2